All right, so here's your free response question of the day. It's the actual question used in 2017, question number 5 for the free response. So in the question, you're told about two particles. One's P, one's Q. For P, you're given the position, and for Q, you're given the velocity. And you're told the position of particle Q is 5 at the beginning. Initial position is 5. Now we're going to answer the questions. So for A, from 0 to 8, when is particle P moving left? So we're not even looking at Q, just P. When is it moving left? And how do you know? So the answer is the velocity of the particle tells me whether it's moving right or left. So if the velocity is positive, it's moving right. If it's negative, it's moving left. So step 1 in A is to find the velocity. So the velocity of that is simply the derivative. Now, how do you take the derivative of a logarithm? It's a fraction. What you see is in the denominator, and the derivative of that is in the numerator. So what you see is in the denominator, the derivative of that is in the numerator. I want to know if it's moving left, when is it negative between 0 and 8? So first I'm going to see if I can actually factor this to help me out. So the numerator, when I factor it, I can factor out a 2 and I get t minus 1. When I look at the denominator, I have 5 and negative 2. No, it's not factorable, is it? Haha. Because 5 times 2, but it doesn't subtract to 3. So it's not factorable. So first of all, here, if I look at the numerator, when is the numerator negative? So you can tell that between 0 and 1 would give you a negative answer. So if it's 1 or greater, the numerator is positive. So I know that so far. Everything else would be positive. If I plug in values here from 0 to 8, is there any time that would give me a negative answer? So if I plug in 0, no. If I plug in 1, if I plug in 2, if I plug in 3, see the vertex here might be helpful. That's negative b over 2a. So the vertex would be at negative 2, that's 2, and 2, so it's at 1. So the vertex is at 1. So if the vertex is at 1, if I plug in a number between 0 and 1, that answer is positive. If I plug in 1, the answer is positive. And then from there, it's just going to keep increasing. It's a parabola that looks, like this, concave up. Once I found the vertex, all the answers are always going to be a positive answer. This whole parabola is going to give you a positive answer from 0 to 8. So t squared minus 2t plus 10 is always greater than 0 from 0 to 8. So therefore, when is this particle moving left? Only when the numerator is negative, and it's only negative from 0 to 1. All right, part a little bit tricky, right? Just the number sense quadratic algebra part, not the calculus part, which I always feel discouraged when AP does that, when they're trying to just test your algebra rather than just seeing what your calculus is like. So anyways, that was the tricky part, to understand that the denominator is always positive, no matter what number you plug in between 0 and 8. And the numerator is only negative from 0 to 1. So there it is. From 0 to 1, it's moving left. Part B, find all times in which the two particles travel in the same direction. So for traveling in the same direction, we're looking at the velocity for both. So for P, we just found out from 0 to 8 that at 1, so it goes left, and then after 1 it changes direction and it goes right. The velocity for Q, we have to look at still. So the velocity for Q, let's look at what that is. It's t squared minus 8t plus 15. So that's definitely factorable. So if we factor that, what are the two numbers that multiply to 15 and add to negative 8? So again, we're looking at this right here and factoring it. So where are the critical numbers at 5 and 3? And then it's a parabola, so it's changing every time. So what does it start with and so on. So if I plug in a number between 0 and 3, like positive 1, 0 to 8. So if I plug in 1, I get a negative times a negative, which is positive. If I plug in a number between 3 and 5, 4 is a negative and a positive. If I plug in a number bigger than 5, it's positive. So we have our signs now to understand what direction they're going. So when are the directions going the same way? So from 0 to 1, no. But from 1 to 3, they match. And from 5 to 8, they match. So from 1 to 3 and 5 to 8, both particles are moving in the same direction. All right, part C. It says find the acceleration of Q at time t equals 2. So I'm going to do that on a separate piece of paper here. Here's 2017. This is free response question 5. We're now on to 5C. Acceleration is the derivative of velocity. So for Q, what is the acceleration of Q? The derivative. So what's the derivative of this up here? So it's 2t minus 8, nice and simple. Plug in 2 for the time, and that's it. And answer it. So the acceleration is negative 4. Do the same thing. And then it says what? Is the speed increasing or decreasing? Well, the speed is increasing or decreasing when the sign of the velocity and acceleration match. So I need to know what the velocity of it is at 2. So if I look at the velocity at 2, you have 2 squared subtract 8 times 2 plus 15. So that's 19, take away 16, that's 3. So notice the signs are different. So the particle is decreasing. So the speed of particle Q is decreasing at t equals 2. Why? Because the acceleration at 2 is less than 0, and the velocity of Q at 2 is greater than 0. So because the signs don't match, and that's great, that means it's decreasing. If both were negative or both positive, then the speed would be increasing. All right, part D. Last one. Find the position of particle Q the first time it changes direction. So let's go back and look at Q again over here. When does it change direction for the first time? Q. And you can see it changes direction for the first time at 3. And what's the position there? So let's look at that. So we're looking at 3 for when it changes position for the first time. We get that off the velocity. Now, what do we know about Q? So in the question, it says the initial position of Q is 5. So if I want to know the position of Q at 3, we start with what we know. So at 0, when t equals 0, it says the initial position is 5. So we start there, it's 5. And then we're going to integrate from 0 to 3. We're going to integrate the velocity, and that will tell me the position at 3. So we started at 5. The integration of the velocity tells me whether it increased or decreased from 5 and how much, and that will give us the answer. So can you integrate the velocity? So this is a simple power rule here, t squared. So add 1 to the exponent and divide. So that is t cubed divided by 3. The next one would be t squared divided by 2. So just do the anti-power rule. And the last one would be 5 or 15t. No need to simplify this whatsoever. And we're integrating from 0 to 3. So the step 1 is to plug in 3. So it's 3 cubed divided by 3, 3 squared divided by 2, and then 15 times 3. Now I can see this. When you plug in 0, and it's obviously the answer is 0, so that's it. So you can go subtract 0, nothing else. It's just 0 after that. You don't have to simplify that, and that's the answer. So the position of particle Q at 3 is this answer. If you did simplify it, the answer was 23. All right, you did your work. Good job, Mr. G Math. Over and out. Thank you for working with me. Till next time.